I wasn't planning on presenting today, but here I am. Sorry about that. And I didn't actually really finish the presentation, but it's good to have a point in time update. So we'll do that. And then if there's questions or, there needs to be more, we could do more. Um, so our public internet network has been changing over the years. As of now, it kind of looks like this. We have Supernode 3 that many of us are familiar with, Supernode 10 and Supernode 11. Why they're not sequential numbers is a different story, but that's the way it is. And so you see we have about 100 gigabits of internet access, which is kind of cool. That's actually quite a bit for a very small group like ours. That's something that we should be very thankful for. We're on a couple exchanges and we have a very benevolent ISP. And the slide I wanted to put on here that I didn't put on is, if you see we've had a recent couple outages where it's due to kind of like lack of redundancy in some of these. And I hope that we can begin to address that by combining some of these that I'll talk about later. But yeah, anyway, our spread is basically about 100 gigabits of internet access. Not that we can use all of it, but we have it. About 50 peers, about 1,000 public IPs. I would guess that we're serving about 5,000 people daily. Maybe other people can give a different number, but it feels like that because it's about 1 megabit per person on average, 1 or 2. So somewhere between like for general internet usage in the evening time on average. So 3,000 to 5,000 people, maybe 2,500 to 5,000. And so we'll talk about Supernode 11 a little bit specifically. This is our newest one. It popped up last year. It is this building on Hudson Street, 325 Hudson. It has about 100 participants in the Meet Me room, and we are one of those participants. So compared to some of the other locations where we were also in the Meet Me room, this one is very flat in terms of the hierarchy. We can easily connect with anybody we want to in the Meet Me room, and it's flat cost for all of those things. We have a third of a rack, about 3 kilowatts of power. And so far, we've connected with dark fiber to Olmsted and also DKIX 10 gigabit, which was an upgrade for us. And I'm hoping maybe in 2025, we can move some of the connections from Supernode 10, which is kind of falling out of favor, over to Supernode 11. And if I go back a page, you'll see really we have this, and then we would have 2 major locations that have redundant connections, kind of. And so that would be a big help, I think, for our stability in the future. So moving on, our presence looks like this. Most of us, all of us, have not been to this location yet. So for those who are curious what it looks like, this is actually our smallest and simplest location yet, which means that we can grow quite well there. We have a panel to the Meet Me room. So as I mentioned, it's very flat hierarchy for us to be able to connect to anybody. Everyone has the same panel and they're all in the same room. There's not tiered Meet Me rooms or anything. We have a nice big switch that we're using other places too, all 40 gigabit and 10 gigabit. And we have a server that's routing using this VPP thing, and also now for mesh services. And I hope we have a few more after that. A note about the VPP thing, which is kind of also what I wanted to talk about in this presentation. A few years ago, we had some presentations on it, and it was kind of under development. At this point, it's been routing Supernode 11 for quite a while, half a year or so, and it's doing a stellar job, I think, in terms of the performance. We really haven't actually had to have any problems with it, whereas we do with other locations. This was the test I initially performed, a computer on the side, which is now actually the one we have in production. At the time, I tested with 100 gigabit adapters into that very same Juniper switch that you saw in the picture. And then I put it through, this is my test system, through that very same Juniper switch and then into the server that is being used right now. So this is the switch this is the server layout that kind of mimics what Supernode 11 would look like in the past. And the results, if we look at it here, the things highlighted in bold are kind of the maximums. So here, because that was a 40 gigabit test, 4 times 10, we hit just under 38 gigabits per second. On this middle test right here, the top test, this millions of packets per second is a card limitation. So that's the maximum that the chip and the network card can do. And this middle test, that was the maximum that the test server could do. So in any case, we maxed out everything that was possible. in any one dimension, unless we change the rig. That's what we could get. And another nice thing about this, now that this is in production, if anyone knows otherwise, let me know. But we typically have some kind of IP collision problems on other older supernodes where we have too many members behind certain public IPs. And we fan those out over time to prevent this problem. But we prevented this problem from the beginning with Supernode 11 by hashing the inside IP in the mesh to a unique outside IP. And so any one member from their one computer, their one device, will always get the same public IP on the outside. And so they should never change mid-usage of the mesh until they get a different IP inside. So that's a big improvement as well. And if anyone knows that it works otherwise, let me know. If you find that this is not happening, that would be a good bug report, right? Yes. And so this was done by, a few years ago, we bought these Dell servers. This is a disorganized slide, so we should update it. But, it's finished having these Dell servers used for VPP and other things. It's finished to have these special network cards that are doing a good job. It's finished to have sticky NAT, or this kind of CG NAT we talked about. What we should do from this point, now that 11 is working, is we should buy more hardware so we can deploy this in other locations, specifically Supernode 3 and Supernode 10, 3 especially, which is frequently overloaded, and then more servers so that, I think this was a success in terms of having bought the servers because we used all of them for something, right? And so we should buy more. We should buy some for mesh services, we should buy more for routing, we should be more redundant with our routing. And so this is kind of a call to action to say, like, yeah, let's do it. And yeah. So questions, I have a few more slides just for fun. I put them after in case we didn't have time. I've performed other tests with this. I don't know if I actually showed these here or not. I've showed them somewhere else. But I mentioned that the testing rig was too small and we hit the maximums of it. So I have a lot of extra hardware at home. And so I set up multiple of these test rigs with multiple 100 gig cards. I got rid of all the switches and I plugged them directly into that same server that's currently in Supernode 11. And this is what we're using in production right here. And that's what I did the test on. I discarded that. I just left on the side. And I put my own 100 gig cards in on a different socket. And I was able to, it looked kind of like this. Actually, I don't know if I showed this to Mesh or not, but, and what did I get? I got, on an HTTP test, I did some more tests. I got 176 gigabits per second on the 1U server. And then, back in the 40s, 160s. So you can see that the numbers really climbed up. The limit was not the computer, it's the network card. And then those other things that had these millions of packets per second limitations, they've doubled basically, and the latency's dropped by 10x on some cases. And so we can, basically this iMix small is kind of like internet. So we can easily consume way more bandwidth with our system with $500 network cards added to these systems than we even have available. And yeah, this is more like a Netflix streaming scenario. This is more like a browsing the web scenario, right? So anyway, there you go. Any questions?
Can you explain, we had an enormous savings in the server hardware, didn't we, by using VPP? Can you explain that?
You mean compared to a commercial option?
Yeah.
Yeah, if I go to a very old presentation, I decided not to bring these over, but here's an old slide. Our other options, kind of VPP is like the best option of all the bad options, and they all have problems. But like the typical solution that we would, if we were like an ISP that wanted to make money and do a good job, we would buy some kind of larger commercial router that would be, if we bought it new, even used, it would be, 30, 50, 100K. You can't modify anything on it. It does certain things, but it is fast. And usually you want to have, they have bugs too, just like VPP does, but you need to work with a commercial vendor, have a support contract. You're looking at $10, $20, $30,000 a year just for support. So we didn't do any of that. And really we could, but there's not very many good options on the market that can fit the whole internet routing table and route fast enough. And so we would be really stuck at a minimum, as we couldn't really get away with something less than 50K. There's some exceptions. There's a couple of things we could do, but they're like hacky, right? So if you do something hacky, you might as well do something all the way hacky, and so that's what we've done. There's some other options. We currently on our other super nodes use, we don't use BSD, but we're using a Linux router. That doesn't cost us very much and it's easy, but you can really only get about 5, 8, maybe 10 gigabits of kind of like real traffic through it. You can do a synthetic test and get a full 10 or a little bit more, but like real internet traffic, as it was kind of obvious in this one, I mean, not obvious, but different kinds of internet traffic, even on a really good routing platform, have a very different profile, right? Like just DNS queries, you get this, but then if you're like Netflix, then you get something like these ones, right? So you can do 4 times as much Netflix video streaming as you can like regular web browsing, right? Just because of the nature of the traffic. And so the same in, same in like a Linux router, or even what we do at Supernode 3. If we do a synthetic test, we can get the full speed. But if you have 1,000 people doing stuff, you're down to a quarter of the speed, right? And so that's where we're at for that. Other questions?
I was just curious about the public IP portion you mentioned. You said there's like hashing algorithm that determines what your public IP is. So like how would that change? And then what is the total number of IPs that there are used?
Yeah, so the whole mesh is on private IPs, and we NAT to public IPs on the edge on these supernodes. So you could have like some node in Brooklyn, and today it could be exiting to internet through Supernode 3, but maybe there's some outage and now it exits through Supernode 10, right? And so we don't map the IPs one-to-one. We have to kind of like say, whomever can get here, we have to find a way to get you out, right? And if we put everyone behind one IP, which we used to do, then, when you hit Google's like, I got 1 million requests from this IP, it must be a bot, right? And it's not a bot, it's a bunch of people. So to make that a little easier, we need to distribute people across many public IPs. And we were doing that in a bit of a static way, so that like if this building has a lot of people in it, they might all exit through the same IP. But now with the new hashing algorithm that's in VPP, it's in the NAT code. Multiple people in the same building may be on different public IPs, so it kind of more evenly distributes it across people who are, across the whole mesh, right?
So what's the total number then?
So we have about 1,000 IPs.
All used? Oh, okay.
No, not all used, because the way we distribute them is sort of by supernodes. So we have some here, some over there. Some are used for other purposes. Some are given to people who need them, help stack IPs. So it's about 1,000 total that we have control of, but a few hundred are used for matter. Yeah.
Do you know how like Starlink does it? Because I know that they have all.
Starlink's a different situation. So all commercial ISPs will basically give you a public IP on your device.
Yep. No, that's regular Starlink. You don't get a public IP.
Okay, well then they must do something like this. There's very large, like in the large category, you can buy a Juniper device that's about $500,000 that will do full NAT for a couple hundred gigabits per second. So if you were a real ISP, you would probably buy this $500,000 solution.
But I mean, they would have the same issue about thousands of people from one IP.
And they can NAT you one-to-one though. Yeah, they could send like one customer out one IP. Yeah. There's a lot of options. There's a ton of ways to do it, right? Yeah.
Yeah, the big difference between us and a commercial ISP, right, is almost every commercial ISP will distribute their own hardware at the customer side. So like the cable modem, the Starry, whatever it might be, and they'll assign it to that. And most of them will charge if you want a static IP these days because they're literally running out of them. We don't really do that, right? We don't, like, you can hook your laptop up to the mesh and be, on the mesh network without being behind a router. We don't have any sort of like authentication or, MAC control or anything like that. Whereas almost every commercial ISP, you couldn't just plug a random device into it and get access. That's the big difference.
How different is the setup for a VPP compared to like a normal BSD router?
Yeah, so I wanted to draw a diagram to show because it's a little complicated. I didn't have a chance to get. I have a diagram at home, but I wasn't home. It is a bit different. It's still a routing thing, but instead of like a MikroTik router that we use, it has an IP and It has like firewall rules and stuff like that. It has some services. VPP is not. It's kind of just this raw animal that you like feed packets to it somehow, and then it just like it receives them and just processes them, and it puts it out the other side. So the reason we need to have the Juniper there, for example, the Juniper really is actually doing all the work, and there's rules in the Juniper that say if this packet's coming in and going out that way, then insert this line in the ASIC and the chip to bump it to this port, and then it goes to that port, and the VPP is like, whoa, and it just processes it and sticks it back in. So we have like 4 VRFs, virtual routers within this, and those are all the actual router, and VPP is kind of like a bump in the wire that processes the data. So kind of. Right. I would love to have a diagram, but then I thought actually maybe going over a diagram for half an hour might not be everyone's favorite
Yeah,
thing.
some
to
other
do, so,
time.
yeah, that might be a hack night thing.
Are there any opportunities for cross training on this?
I don't understand what that means. What's cross training?
Sorry, cross training like
Oh, cross training. Yeah, sure. Yeah, of course.
Quick question. So I think the other supernodes are using MikroTik gear, or at least one of them is using MikroTik both for NAT and for core, right?
Sure. Yeah.
Is it possible to run the equivalent speed tests on those just to see
Yes.
how bad they are?
Yeah. So this setup that I had here, excitingly, there's a bunch of 1 gig port or 10 gig ports right here, so I can just plug those in a different way. So yeah, I could. I don't have those specific models, but I could run the same kind of tests on those. Yeah. These are reproducible. That's kind of why it's nice to have a lab environment. Is I could just swap this out with whatever.
Yeah. So if we have a spare MikroTik in the mesh room or something, we can
Yeah, for sure.
send that home and run these tests.
Yep.
Cool. Thank you.
And we have that 72 as well, which is that'd be interesting.
Oh,
to do.
yes.
Yeah.
That would be interesting.
Cool. Okay. All right. Thanks.